Okay. Power versus energy. Unit of power is the watts. Unit of energy is the joule. Symbol for the unit of power is W. The symbol for the unit of energy is J. The symbol for power itself is P. The symbol for energy itself is E. You have to know those to be different things, separate units. 1 watt is equal to 1 joule per second. Okay, so if I've got 20 joules of energy in 1 second, that's the same as saying 20 watts. Power is equal to energy divided by time, or if you're talking about electricity, power is equal to current multiplied by voltage. The rate of flow of electrons multiplied by the push that's given by the battery. I can also write this down as P is equal to I times R. Why can I write it down like that? Because V is equal to I times R. So instead of writing V, I can write I times R. This then gives me the equation P is equal to I squared times R. Why is that? Because the electrons carry the joules around the circuit. If I push my electrons more and there's a higher rate of current, there will be more power transferred, more joules per second. In electricity, 1 volt is equal to 1 joule per coulomb. 1 packet of energy per packet of electrons. So a volt is a certain amount of energy per coulomb. If I increase the voltage, I increase the amount of energy that coulomb is able to transfer to different circuits. Power is equal to energy over time. This can be work done as well, or it can be any of the other types of energy. So it can be the force multiplied by distance, it can be the GPE, it can be the kinetic energy. Okay, so this top bit here, that can be any of these different types of works. The time, if you're putting it into watts, has to be put into seconds. Okay, it has to be over seconds if it's going into watts. If I did something like, what's the power if I've got 10 joules over 10 seconds, that would be me saying I've got 1 watt of power. If I was to say, what's the power if I've got 10 joules over 10 minutes, that would not be equal to 1 watt of power. I've got to turn this into seconds. 10 minutes, 600 seconds. No. Yeah? Yeah. So that's 1 over 60. What's that? Anyone know in their head? Okay, it's a number. Oh, wow. This is the Educate homework for my class. This is the lesson I was just teaching. This is slightly embarrassing. Oh, the whole thing shut down. Cool. Hey, cool, brilliant. We'll sort this out in editing. Just do some music. Do 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 do. Ansel. Okay, so I'm just going to be. Yeah, that's true. With the dance. Who's going to volunteer to come up and dance in the middle? Cody, will you just go up to the front and do a little dance? Yeah. Oh, there we go. Sorted. So I'll just go back into the pose that I was. Yeah, okay, like this. Whatever number that is, watts, right? Listen up. If we're working out the efficiency is equal to the useful divided by the total. This can either be work done, i.e. energy, or it can be power. You have to be careful when you're looking at your units, when you're looking at your questions, okay? If it's talking about power, it'll be watts. When it's talking about energy, it will be joules. Power isn't the same thing as joules. I also need to talk about efficiency when it comes to electronics, okay? So we have got a power station, we have got a transformer, or we've got a domestic supply, and in between those two, we've got a transformer and we've got a transformer. This is a step up, this is a step down. Are we aware? Hopefully we should be aware of this. Power station produces electricity at a certain voltage. Step up transformer goes through the power lines at a certain voltage. Step down transformer changes the voltage for the domestic supply in our homes. 25,000 volts is generally what's supplied in a power station. Goes up to 300,000 volts in your power lines, and then it comes down to 230 volts for your domestic use. Why is it that it goes up to this high voltage? Because when I've increased the voltage, I decrease the current. Why do I decrease the current? Because P equals I squared R. The amount of power lost in a transmission wire, so this is just in the transmission bit, is equal to the square of the current multiplied by the resistance. Why do I change the voltage? It's so I can decrease the current. Let us say I had 20 amps of current here, and then that changed to 2 amps of current here. That's incorrect, but let's just pretend. 20 squared is a lot. 400, is that right? Okay. Because I do what I want. It would be 400 multiplied by the resistance, which let's say is 1. So the power loss would be 400 watts. If I change it down to 2, it will be 4 watts. So without my step-up transformer, the power loss here would be 400 watts. But now I've changed the voltage and put down the current. I've changed it to 4 watts.